This is Christian Ramos,
And this is James
and
Peterson.
this is our news vendor homework problem extra credit presentation. So we own a sports equipment store called Home Run Sports, and the baseball season is fast approaching, so we're gonna have a big stream of customers coming in to buy the newest baseball gloves for the season. And the store, we will buy the glove for $20, so that will be our variable cost and sell for 45. That's our price, and we really value customer service. So if we do not have gloves in stock, we will then sell it to a customer at a discounted rate of $20, and then we'll give them a $20 store voucher. So that's our back order cost. And then if we have any extra gloves at the end, then we have a $10 salvage cost. And as you can see there, we have a discrete distribution for our demand. So 100 is 1/10, 125, 1/10, 150. We 3/10, 175 is 4/10, and then 200 gloves ordered happens 1/10 of the time. So part A, what is the optimal order quantity for home run sports to maximize profit? So for this, you need to find the criterion value, and I have an f of y value that is greater than the criterion value. So how do you find the criterion value? That's P, which is price, plus B, your back order cost, minus CB, your fixed or your variable cost, over P plus B, same as before, plus H, which is your holding cost. So we plug that in, 45 plus 20 minus 20, and then 45 plus 20 minus 10. Keep a note, we have a salvage value, so that means that the holding cost is negative. That's what's a negative 10, not a positive 10 there. And then we find that that is 0.818. So then we go over to our CDF, and our y value is on the very far right of the table, and that at 175 is the first time where that value is over 0.818. So that's how we get our y star value of 75 baseball gloves. And then what is the optimal order quantity for home run sports to maximize profit? If there is a fixed ordering cost of $500, it's still going to be the exact same because the fixed cost does not play a role into calculating the criterion value. So that doesn't affect anything. If we have a higher ordering cost or lower ordering cost, we still want to order the optimal amount of 175 baseball gloves.
Yeah, so then moving into part C, we're looking at the expected profit for home run sports when they order the quantity of gloves to maximize profit. So for this, we go back to part A where we found that the optimal order quantity is 175 gloves. And then you look at that first line and its expected profit is equal to the price times the expected value of the minimum of y star, which is 175, and demand, minus the variable cost times y star, and then minus the holding cost times the maximum of y star minus demand and 0. So if y star minus demand is a negative number, then that'll just be a 0. And then a similar thing with back order costs, except demand minus y star and 0. And so when you start doing all the math, you see we get a bunch of numbers here. So the expected value of the minimum of 175 and demand is 155. Expected value of 175 minus demand, the maximum of that and 0 is 20. And then on the flip side, the expected value of demand minus 175 with the max of 0 is 2.5. And that all boils down to your expected profit when you order 175 gloves as $3,625. Now we're assuming that demand is uniformly distributed between 125 and 175 gloves. What is the new criterion value? So this is a very similar process as part A. You have the same calculation where you have price plus backorder cost minus variable cost over price plus backorder cost plus holding cost. So you get this 0.818 value again. The difference here is you have to calculate the CDF of a uniform distribution, which is x, or in this case y, minus a over b minus a. So that winds up being y minus 125 over 50. You set that equal to 0.818. And this yields a y star of 165.9. So we're just going to call that 166 gloves as the optimal order quantity because you're going to want to round up. You can't order a decimal amount of gloves. And then for part E, assuming we order the quantity we found in part D, which was 166, what is the expected profit? So similar to B, except this time the expected values involve a bunch of integrals. And it's not as scary as it initially looks because there's ways to kind of work around this. So when dealing with the expected value of the minimum of 166 in demand, you have to split that integral up. So from 125 to 166, we can replace that with y. because for any value less than 166, you're going to take the other value, which is just some value between 125, 126, or 166. Once you exceed 166, the minimum will just be 166, so that's why we replace it there. And then for the expected value of the maximum between 166 minus demand, you can actually make that integral the bounds between 125 and 166, because once demand exceeds 166, that term's going to go to 0. And then conversely, when you have demand minus 166, the maximum of that and 0, the bounds will be between 166 and 175, because when demand is less than 166, it'll be equal to 0. So you add up all those numbers, plug them into the expected profit formula, and you'll get an expected profit of $3,543.85. Thank you so much for watching.